today I'll be discussing with you how Hansen used StreetLight to collect turning movement counts during COVID-19. So the first project I'll be going over is the Brownsville signal modernization plan we did with the city of Brownsville, Texas. So this project consisted of an analysis of the delay and capacity of all 200 signals throughout the city. And through our first stage of work, we had to analyze the capacity and delay as well as some other features, and we prioritized the signals throughout the city based on which of them needed updated timings and infrastructure the most. The second stage of work included providing new signal timings for the 50 signals that we deemed the highest priority. And on the next slide, we can see that by the time we reached the second stage of work, COVID-19 hit the US. And obtaining accurate traffic counts was no longer feasible because the traffic that the city was experiencing was highly irregular and not representative of what we expected the traffic would be in the future. So under the assumption that traffic volumes would eventually return to a similar state to what they were before COVID, StreetLight became the perfect tool to allow us to retroactively find traffic turning volumes. So our process was to collect the traffic turning volumes using StreetLight. We used an origin destination analysis type and set up multiple pass-through zones throughout each intersection. So these pass-through zones were set up into two zone sets for each intersection to capture the vehicles coming into an intersection and those leaving. On a typical four-leg two-way intersection, you would see four distinct zones because vehicles are entering and exiting the intersection in the same way. However, there's intersections like this one shown here where there was more than four legs or there was one-way roads, and in those cases you would have irregular zone configurations. So the zone setup varies per intersection per configuration, but once all the zones were properly oriented and positioned for each intersection, we were able to enter each zone set or each zone set pair, because there's entering and exiting for each intersection, into an analysis that in our case collected volumes from 2019, the most recent year of data that wasn't affected by COVID, and in the months of February, March, April, and October, because these were the most representative months of the entire year. They had no major holidays or major vacations that would cause traffic to be irregular throughout those months. And we also analyzed our traffic volumes for the smallest time increment that was available in StreetLight, and that is hourly volumes. And we analyzed all of our volumes for mid-weekdays, as in Tuesday through Thursday. And this is the zone set for this specific intersection. This was both the entering and exiting. All right. So for the results, when the analysis was complete, there's visualization features in StreetLight that were able to represent the data in a variety of formats. You can see here some of them. There was bar charts that could show the highest volume movements by leg. There's heat matrices, chord diagrams, etc. Looking at these visualizations was very helpful in making sure that all the inputs were correct from the previous stages, getting a sense of the general traffic trends, and double checking your work. However, for our purposes, we ultimately exported all the data to Excel, and that's where we really dug into that data and were able to do further analysis on it. So interpreting our results. After exporting the raw traffic data to Excel, we did volume balancing for all of the volumes per roadway segment. So for reference, we split up all of the roadway segments into about 5 to 6 signals. It was like a chain of 5 to 6 signals along each roadway, and we balanced these volumes per these corridors. So while balancing these volumes, it's important to note that we allowed for a much higher imbalance tolerance than we typically would when using single day traffic counts, because we understand that the traffic counts we're using are an average over multiple months. And in our case, in only 1 year, however, the time span could be much longer. So we did allow for a higher volume imbalance tolerance. Um, However, when we were done balancing the volumes, the data was ready to be implemented into our modeling softwares, and those modeling softwares ran perfectly, and we were able to retime our signals based on these turning movement counts.